Okay. Oh, wow. You're all so early.
Yeah, thanks a lot for joining, and welcome everybody. So I'm going to talk about misconceptions about continuous delivery. I'm glad to be here, and thanks for showing up. Thanks for having me. So my name is Eberhard Wolff. I'm with InnoQ. I'm a fellow, so I mostly do consulting and training. I have a Twitter handle and a homepage, as you can see. I've actually written a few books. So I've written a more technical book about continuous delivery. I've written a book about, well, microservices as an architecture approach, and there is a free booklet that sort of sums that book up. And I've also written a book about technologies, how you would implement microservices. And again, there is a free version that sums that up. And the last one that I did is a book that Hannah Prinz, my colleague, and me wrote about service meshes, a nice technology for doing microservices. So the question is, why am I even doing this talk? Oh, by the way, so there is a Q&A. So if there are any questions, feel free to ask them in the Q&A. And I think we have some time to answer them at the end, and I'm really looking forward to that. So answering questions and having a discussion is actually what I enjoyed most, and so I'm more than glad if you ask any questions. So that's that. So why am I doing this talk? So continuous delivery is something that is actually has been around for quite a long time. I think the original book even has been written in 2010, and I would argue it's still not very well understood. And it is something that agility also has as a problem. And people want to be agile. People claim that they are agile, but as a matter of fact, often they are not, and they don't really understand what agile is. So I want to help understanding continuous delivery, and so that we can actually reach the objectives and really understand how continuous delivery helps. And therefore, I want to talk about a few misconceptions that you might have, or that I see in a lot of customers. So the first one is probably, so if you do a release, why would you do a release? Because there are new features, obviously. And sort of the thinking behind that is, well, if you do a release, that's actually a risky thing to do because things might break. So it only really makes some sense if the person who's using the software actually has some advantages, like, for example, new features. Well, I would actually argue that this is risky. It is risky to tie releases to new features because sometimes, well, features have a certain deadline, and in some cases, those deadlines are actually hard in the sense that there are some regulations that are start being in that need to have a change in place on the 1st of April or so, or otherwise you're actually doing a felony or something is really, really bad. So, and in that case, there is a problem because it actually means if you tie your release to that new feature, then it means you really have to get that right by the 21st of March or whatever. If you don't, you actually really have a problem. So I would argue you should actually release much earlier than such a deadline, and you should probably try stuff out in production. And oftentimes, well, the question is, but you will have half-finished things in production then. Well, actually, there are feature toggles, so you can disable a feature, and you can say, okay, this is not really cannot really be used by users out in the wild. It is just there in the code, but it really hasn't been activated yet. And if you look at it, so this is my telephone. It's an Android phone. And again, this morning, well, I took a quite busy day there. So on that day, it was actually 20 updates or so. So this morning I got 6 updates or so on my telephone, and I'm not even sure when I noticed a new feature the last time. Probably it was Google Maps. And actually the new feature that I noticed was the new icon. So that's not really a feature, I would argue. And also, I'm not sure when I noticed a bug fix the last time. And that's the same for Windows. So I'm on Windows, on a Windows machine here, and I do regular updates, but I'm not sure when I noticed a new feature the last time. And the same is also true for the applications on my laptop. So if you think somehow those releases are tied to new features, why is it that I hardly ever see new features in the software that I'm actually using? So that seems weird. I would argue that actually the features are probably not that important. So the question is whether there are any other reasons why you would do a release. And obviously there are some more or less obvious reasons that come to mind. So you might want to do bug fixes, you might want to do some security fixes, you might want to integrate a new library with bug fixes or security fixes, and therefore you should probably have, well, more security, less bugs. And if you don't have a system in place that allows you to roll out new software into production, you will actually run into security problems because, well, there are problems, there are security holes, so you eventually need to fix them. But still, I would argue that a release is new features. Tying releases to new features actually doesn't really make a lot of sense. So for that reason, you should first of all decouple releases and features. So if you roll out a new release, that should include part of a new feature, but to actually get that feature into production, you should just toggle a feature toggle. And maybe there are other reasons for releases. And at the core, I think there is the misconception that continuous delivery is actually about time to market. So if you ask people why you would do continuous delivery, well, it is because it is so easy to get features out on the market then, and then you gain an advantage in the marketplace because your software is more up to date and you have the latest features. And I would argue that there is more to it. So first of all, there are feedback loops, and to actually get anything useful to get done in complex scenarios such as software development, you need to have some loops in place to see whether you're on the right track. So there should be some loops that tell you, well, I'm heading in the right direction. And that is probably more important than to plan ahead and say, okay, this is where we want to be in 2 years or so. I think it's much more important to see how I actually see whether I'm on the right track, and you can have KPIs such as revenue or how many hits you get on the website and so on and so on. And this is, I think, in particular important in complex scenarios where you're not sure how people actually behave, how your customer behaves, and so on. And if you look at software development, there are actually quite a few feedback loops. So, you do a deployment and then you get customer feedback. So that's the one feedback loop that I'm going to talk about a lot more. Then there might be a feedback loop where you do a deployment and you get feedback from monitoring. So you put the system in place in production, you see how your monitoring behaves. So that is feedback that allows you to get some information about how you're doing in terms of performance, for example. And every time you do a commit, you actually get a feedback from the unit test. So if you look at this, these feedback loops there are quite a few of them. These are dependent on deployment. This one is actually a feedback loop that I do probably several times an hour. And this is one that I do every time that I do a deployment. So I would argue that you want to go through these feedback loops as often as possible. And for that reason, you get with continuous delivery, you get an automated pipeline, and it then makes feedback much cheaper. So you can actually go into the market, get some feedback from the marketplace. And for that reason, you can also execute the pipeline much more often and then you get feedback more frequently. And this is all about, going to the marketplace, time to market, feedback in terms of features. And that is sort of obvious. And it is actually the way that I tried to pitch continuous delivery for quite some time. But I would argue that there is more to it. So if you look at continuous delivery, it is the way this works is very closely related, I would argue, to the lean ideas that are around from the Toyota production system. So lean is something that also Agile sort of relies on. And the idea is to get a constant flow of something. So if you build a car like Toyota does, basically what you do is you get some iron into the factory, and then at the end, cars come out of that. And the idea of the Toyota production system is to optimize for flow. So there should be a constant flow from the raw material to the finished product. And this is quite a different optimization than what a lot of people are used to. So if I'm producing doors, for example, for the car, what I would be doing here is I would try to be part of a constant flow. So if I'm standing at my machine and producing doors all the time, and doors pile up, that's actually a problem because there is no constant flow. And what you would do to make that a constant flow is you would say, okay, the limit of doors that you're allowed to produce is, 5. And if 5 doors are on the stack, then you stop producing them until some doors are taken and, put onto cars. And that way, the reason why you want to do that is because then you get an idea about what the problem is. So if doors pile up, it means that the next step in the production actually has a problem. So we should focus on that. So it sort of automatically identifies bottlenecks. And I would argue that continuous delivery is actually a very similar approach. So I'm obviously not an expert on automobile production, but I think sort of the spirit is basically very similar. So if you don't do continuous delivery, there are these stages in the continuous delivery pipeline, like the commit stage, where you do the unit tests and maybe static code review, static code analysis, the automated acceptance test, where you look at the system and try to figure out whether it is actually what the customer wants, capacity test, where you figure out whether the system has the performance that you need to have, and then finally explorative testing, where you take a look at the whole thing and you have some testers looking at new features or things of that nature. And if you don't have continuous delivery, what you will do, you will sort of stack up a batch of changes, and that would be your quarterly release or your weekly release or your bi-weekly release. And you would put them through all of these stages. You will put them through acceptance testing, capacity testing, and then at the end, you will go into production. And if you do continuous delivery, the goal is to have a constant flow of features into production. So what you're trying to do, or what you will be doing, is you will increase the speed of that pipeline. And this is sort of like applying pressure to the pipeline. So you're trying to make it faster. You're trying to aim for that constant flow. And then your changes should, be deployed independently and as fast as possible. And you're aiming for that constant flow. So in that case, you will have that single change. You will put it through commit stage. And there it is. It's waiting for acceptance testing now. And here is another change. And that again goes through the commit stage and is waiting again for acceptance tests. And here's another one. And, you know, at one point, finally, one of the changes makes it through acceptance testing and is immediately propagated through capacity testing and goes into production. Now, obviously, we have a problem here, and that is acceptance testing, because there is a huge pile of changes in front of acceptance testing that has piled up there. So this is the bottleneck. So we need to optimize that. And that is very obvious. I mean, if you try to pass through your changes into production and, you know, changes are waiting in front of one of these phases of your continuous delivery pipeline, it's obvious where the bottleneck is. And you can also try to plot that in a different way. So you can take a look at how long a change is processed in one of these stages and how long it's waiting there. And waiting, if you look at agile manufacturing, is actually considered waste. It is not something that the customer pays for. What the customer pays for is, in the case of automobile production, a finished automobile. In the case of software development, it's features that the user can actually use. So it's features in production. So if things just lie around and wait, like the doors or the changes in this example, then it's waste. So, and we can do a plot here. So you could actually go out and try to analyze your continuous delivery pipeline. And you might figure out that the commit stage is actually quite fast, but then there is a lot of waiting going on. We have a somewhat fast acceptance testing phase. We don't really have a lot of waiting in front of capacity testing. And that is also quite quick, and so on and so on. And we figure out that the bottleneck is obviously here because the waiting time is so long. And by applying pressure to that continuous delivery pipeline, you will actually see where the problem is, in this case, in acceptance testing, and you will eventually eliminate that bottleneck. And, you know, then there will be a different bottleneck. So if you manage to make that one phase, like acceptance testing, fast, then probably the next phase, like capacity testing, for example, that might be the next problem. So I would argue what we are looking at here is a sort of an optimization approach to software development overall. So I would argue sort of the expectation that I have if I do continuous delivery is that I'm constantly optimizing my software development process that is implemented by that pipeline. And actually, the way that you're doing that is by increasing speed and by focusing on the outcome, which is software in production, features in production. And the reason why that works is because it actually makes bottlenecks quite obvious, and then it helps to eliminate bottlenecks. So there should be a lot of more advantages than just time to market. So what I'm saying here is that's sort of the hypothesis. If you do continuous delivery, really what you're looking at is a way to optimize your software development process. And that is sort of a bold statement because it's sort of almost like the holy grail, something that we have been looking for quite a long time. And it is a bold statement because, well, there is that paper that says there are no silver bullets in software development. So you should expect that there is not that one thing that actually makes software development a lot more productive. So how can we explain that? Why is that continuous delivery might be that technique to allow you to be much more productive? And is there any proof of that? And it turns out that there is a study that you can actually download freely. And that study talks about the outcome of continuous delivery. So what continuous delivery really has as an outcome and as advantages. And usually when I talk to people, what they say is, well, obviously there is a better time to market. Sometimes people say, well, it might be easier to restore a system that has crashed, because at the end of the day, if you do some kind of deployment. That's basically like restoring a system. It's very similar, but I've done that actually yesterday. So if you talk to people and ask them, well, will continuous delivery, a higher deployment frequency, will that improve productivity overall? And what should be your aim? How often should you deploy? Well, then it turns out that people say, well, I'm not sure about productivity, and maybe you should only roll out if there is a new feature. Okay, and the study, that is what I like about it, actually tells us, gives us concrete answers to these questions. So we don't have to rely on guesswork anymore. So let's take a look at that. The study talks about elite performance and low performers. And the thing that they did is they took all the people who answered the survey and build some groups out of that. So there is a group called elite performers. Those are the ones that deploy multiple times per day or on demand. And the low performers, they do that once per month or once every 6 months. That changes a little bit over the years. So the study has been done several years in a row. Now, again, I would argue just because you deploy multiple times a day, that is not what makes you an elite performer. So again, it's a bold statement. And we should take a look at what the study says, what the advantages are. So it turns out that the lead time for change is much better. That's hardly surprising, right? So if I do a deployment multiple times per day, obviously the change will go into production much quicker than when I do a deployment every month or every 6 months. Turns out that people are also much better at restoring a service that has failed. So that is something that we can prove now. And it's not really that surprising. The change failure rate is much lower, so it's much more unlikely that a change actually fails, which again isn't that surprising because, well, the changes are smaller, so it's unlikely that they fail. But here's the one that people have a hard time to predict. So people who deploy multiple times per day spend 50% of their time working on new work, while low performers only spend 30% of their time working on new work. And that's the 2018 report. So in 2019, it seems they haven't really asked that question. So what that means is the question whether people who deploy more often are more productive, well, you can actually sort of answer it because they spend more time on new work. So it is quite likely that they are more productive because they do more work, well, on new features. So what do they work less on? Things like security issues, bug fixes, end user support, and so on and so on. And I think this is very important because this actually, so if I had a choice, I would rather work for an elite performer because I don't want to spend my time working on security issues, bugs, and end user support. Obviously, it is important to support end users, but it sort of tells me that something is wrong and it's probably not really enjoyable because there will be a lot of pressure because there are problems. So I would actually prefer to work for an elite performer. And that is sort of the reason why I even wrote that book about continuous delivery, to show people how to actually do continuous delivery, because I thought, well, if every deployment just works, that's probably quite nice for us and for us as technical people. And to be quite honest, I didn't really think that much about time to market and the business advantage. So I can relate to that. And I think there are some hints that this might be, this might be fruitful. So there are good reasons to believe that continuous delivery is much more than better time to market. So the outcome is quite clear. Now, the next question is, how do you actually do continuous delivery? Is it just deployment automation? And if you look at it, so when I prepared the talk, I actually forgot about the deployment into production, right? So it's really not that, I would argue it's just the final step in that continuous delivery pipeline, it is definitely not the most important thing. So if you want to implement that, if you really want to have a continuous delivery pipeline, and if you want to introduce that, I would expect that you need to do a lot more than just doing automated deployment. And again, we can take a look at the study here. And what the study says is, here's the percentage of manual work, in this case for configuration management. And it turns out that low performers have, 30% manual work on configuration management, and that decreases. So elite performers have a lower percentage of manual work for configuration management. So obviously they optimize configuration management. The same for testing. Now here's something weird, right? Low performers have a lower percentage of manual work for testing than medium performers, and then it decreases. So I would argue, or that's also what the study says, and I think it's quite logical. So what happens here is, I'm a low performer, so I deploy, every month or so, and now I want to deploy, I'm not sure about medium performers, I think it's like every week. So I try to deploy every week, and part of my tests are automated, 70%. So I can just run them more frequently. And that basically comes for free, right? I just have to have a few more servers, so that shouldn't really be a problem. However, the 30% manual work for the tests, if I do it twice that often, well, it's going to be more effort. So it increases, and I will probably spend some effort into automating them, but that's going to take a while until that actually helps me. So what we are looking at is, we're looking at a stage where the automation didn't really take place, and that happens later in the process. And the same for deployment. So there is some automation around deployment. What I find interesting here is that even for elite performers, all of these things are not fully automated. So there is still some manual testing going on, some manual configuration management, some manual deployment. And finally, there is change approval. So change approval is also automated. And again, there is in the medium performers, there is this higher percentage of manual work. So because you want to do it more frequently, well, you will probably, the automated stuff just scales, but the manual work, that needs to be done more often, so the relative percentage increases. What I find interesting about this is, this actually means that continuous delivery is not the one thing that you need to do. It's actually quite a few things. So it's configuration management, deployments, testing, and change approvals that you need to automate. And if you read through the study more closely, then you will notice that there's actually a lot more that you need to do and that you need to get right. And I think that's the reason why we see this overall increase in productivity. It's because it's not really one thing that we change, but it's rather that we have a general approach how to make things more automated, how to deal with that. And that is also the reason why I don't think there is a contradiction to this statement that there is no silver bullet. This is, again, no silver bullet. It's rather that it points us at several different things that we need to do. It's not the one thing that we need to do. It's actually quite a few things. There is the Accelerate book that the authors of the study also wrote, and it's one of the books that I would really encourage you to read, and that talks in a lot more detail about the sort of things. So I would argue that continuous delivery is actually more like an optimization. So it causes quite a variety of different optimizations, and you will probably eliminate one bottleneck at a time. There's just one warning. So one of the warnings is you must deal with continuous delivery is feedback. So the problem with feedback is feedback actually tells you that you're doing something wrong, or maybe at least suboptimal. Wrong is more like a mistake. So it's more rather that it tells you, well, these are some things that you probably need to optimize. And this is something that you need to deal with. So if something goes wrong, if there is some, if you actually notice that, for example, in the example that I gave you, acceptance testing is the bottleneck, it doesn't really help you if you say, okay, this, someone needs to be fired and, this is all very, very bad, but you need to have a productive approach to that, and you need to make sure that the feedback is actually valued that you get, and that some consequences are drawn from that, and that you realize that you're all in this together, and that you all need to change the way that you're doing things. This is also something that I find interesting. So you have to automate the approval process. So if there are people who say, well, I still need to look at every deployment, that's not going to scale. There is still a way how you can approve new features, because you can actually toggle on feature toggles and thereby activate a feature in production. So, and it doesn't stop there. So what I said is that actually continuous delivery gives you better productivity, but in the latest report, what they said is, well, there is the software delivery performance and availability, which is sort of the metric that is probably most important to you. So how good are you at delivering software? How available is your software? And continuous delivery has a positive impact on that. That's what the green arrow basically says. And what they found out is that actually the software delivery performance is also has a positive influence on the organizational performance. So organizational performance is something that like stock valuation or net promoter employee score. So how likely is it that an employee says, yeah, this is a company that you should probably work for? And one of the other things that actually gives a positive impact on the software delivery performance and availability is a clear change process. And a heavyweight change process actually means that your software delivery performance decreases. So if you try to optimize, if you're in trouble, you shouldn't aim for a more heavyweight approach that says, okay, we need to have more checks and we need to have more control over what's going on. Quite the opposite is true. And this all leads to a culture of psychological safety that again has a positive influence on software delivery performance and availability and on organizational performance. And also it has a negative impact on burnout. So negative impact in the sense that the likelihood that you will burn out actually decreases. So what this actually says is that, so basically you can sum up this slide in one sentence, that is, better life through, it's not even a sentence, better life through continuous delivery, right? And you could say this is again a bold claim, but as I said, I've been there, I've done deployments through the weekend, and that is something that is not really enjoyable. And probably you don't want to argue with that. So, and if I have a clear change process, if I know that every deployment just works, I'm pretty sure that the likelihood that I will burn out is less. So there are more results, and there is a culture of psychological safety. There is less burnout. There is better organizational performance, better market capitalization. The employee net promoter score goes up, and these are all results of an empiric study. And I should add that Dr. Nicole Forsgren, who is one of the authors of the study and also of the book, well, as you can tell, she holds a PhD, so she actually, she did a lot of work on empiric studies on software development. So I actually believe this is sound research, I would argue, and actually asked a question to Jess Humble, another of the co-authors, some time back, and he answered with an email where he said, okay, here are some papers that explain that point in more detail. So this is actually a sort of science. And what I'm doing nowadays is I'm actually going to my customers and ask them, so what do you think? If you deploy more often, what will happen? And I'm sort of still waiting for the person that says, well, obviously we will have less burnout in our organization. I think it's not really obvious. If you think about it, it becomes obvious, but it is not really that obvious. So, and that is the reason why I'm really glad that I can do this talk to talk more about these positive consequences. So I would argue continuous delivery is not really deployment automation. That's another of these misconceptions. It's not really time to market. It is really sort of lean optimization. So it's trying to optimize the processes that I have in place by applying more pressure. And quite a few other things are also wrong. So I had the slide that actually says, well, if I do a new release, that's risky. And that's actually also not true. Frequent deployments decrease risks. So if I do deployments more frequently, that is actually the way to go. So these are some of the misconceptions, and I've talked a lot about that study, and I would encourage you to read the study and also the book. There are more misconceptions. So another misconception that I don't really like is the misconception that DevOps is somehow hiring DevOps engineers. And I'm not even sure why there is this misconception. So originally, the idea about continuous delivery was that, well, there are silos. So there is development, dev on the one side, there is ops on the other side, and there is this wall in between them. And, the idea of DevOps is that these two parties somehow collaborate. And that is one way how you can actually do DevOps. So still having those silos in terms of the organization, but people collaborating and trying to achieve things together. Or you could say, well, I have separated teams for each service, and in those teams I have dev and ops. What I'm trying to say here is the silos, I don't need to change the organization. I don't need to say, okay, you're reporting to someone else. I rather need to encourage collaboration. And that is also something that I sort of lived through. So I've been part of a project where we had separate dev and ops lines or reporting structures. But one of the things that we did there is we had a regular meeting every week where we discussed the most important bugs in production. So there was a meeting with me from dev, someone from ops, and then a QA engineer. And we managed to get that number of problems in production down quite significantly. And that is because we actually collaborated. So we just went through the list of bugs, and for every item on that list, we said, okay, what can you do to fix it from the ops perspective? What can you do to fix it from the dev perspective? And we just went ahead and do it. And I'm not even sure whether the manager sort of officially approved it. It is just something that we did. So there was no need to change the organization at all. Now let's add a DevOps engineers to that equation. Now the question is, what do you do with that person? And you can put that person into ops. And in that point, I would be like, okay, why would I even call that person DevOps engineer? It's just an ops engineer, another part of that silo. And that might help to gain better collaboration or not. It just doesn't matter. So I don't really care that much. Sometimes I see another silo between ops and dev that is called DevOps. And that's, I would argue, an anti-pattern, because you want to have more collaboration between silos, and you don't help that by adding another silo. And in that case, usually what this part of the organization does is it's somehow more closer to to dev. So maybe they're responsible for testing environments, but they are not really responsible for production. And I don't think that helps a lot. So I would argue that somehow, like if when there is someone that I would actually call a DevOps engineer and that I could take seriously as a DevOps engineer, that should be someone who actually makes that collaboration happen. Because at the end of the day, as I said, DevOps is collaboration. And this is, again, something that is related to continuous delivery, because the continuous delivery pipeline sort of by definition is something that goes through all of these different parts of your organization. So roles like QA, Ops, and Dev are all part of that pipeline. And therefore, if you do continuous delivery, you need to have at least some collaboration. Otherwise, you can't really pull that pipeline off. So a DevOps engineer might make the situation worse if the person just adds another silo. You need to somehow transform the silos to encourage collaboration. You need to ensure collaboration. So there needs to be something like mutual respect. You need to incentivize collaboration. So if you have an ops department that is just paid sort of by the server and not because they are supporting projects, well, then that might be something that you want to change. And at the end of the day, this is a cultural shift. And well, I'm sorry for having to say that, because it basically means it's not just hiring a DevOps engineer, it's harder because cultural shifts are actually probably hard to do. And without them, you probably won't have continuous delivery or DevOps or anything like that. So again, I would argue this is really DevOps. So it is a collaboration. And I have to say that I'm not even sure whether DevOps is enough. So if you look at it, we have commit stage. So we have the commit stage, we have automated acceptance tests, we have automated capacity tests, we have manual explorative tests, and we finally have production. So it's actually more that is involved here. So obviously, Dev is responsible for the unit tests and static code analysis and the commit stage. Ops is obviously responsible for production. Now you also need to have the tests in there. You need to have, you need to deal with business feedback. So I would argue what you really need is you need to have QA in there because of the tests. And I'm not saying that there should be a QA engineer. I'm just saying that the role of QA should somehow be in there. Someone who feels responsible for acceptance tests. That might be a developer, but you know that role has to be in there. And also business has to be in there, because at the end of the day, if you have a new feature out there and you say, okay, these are my metrics, this is how successful this feature is, someone has to listen and has to draw conclusions from that and change things into dev. And this is, again, something that is sort of hard to do because you need to have all those people and they need, you know, to talk to one another and they need to have a common goal. And if you don't do that, if you don't have business in there, what you're actually doing is you're building a continuous delivery pipeline, but you're lacking the input from business. And that might be the most valuable part of the continuous delivery pipeline. So without that, there will probably be limited success. And maybe continuous delivery will make organizational issues obvious. And I'm not sure whether that's a bug or a feature. So if you want to do continuous delivery, you probably need to change the organization. So there is a way to tell you that your organization is wrong or that it needs to be improved. And that is using continuous delivery. And I've been in a project where they had continuous delivery in place, where they had that feedback loop to business, but business won't listen. And at the end, the organization that they've built up there, well, they they sort of destroyed that organization because they didn't see the value, because they weren't able to deal with the features. They were still thinking in, quarterly releases, a fixed release schedule, fixed features, and they wouldn't listen to, or they didn't even consider listening to the feedback from production in that case. So there is obviously, it failed miserably, I would argue, because at the end of the day, the whole thing is not there anymore. So this is not true. DevOps is not just about DevOps engineer. It's more like collaboration and culture. And I think the term actually expresses that quite well. It says DevOps, Dev and Ops become one. So how could you have a better name for close collaboration? So in conclusion, I would argue that continuous delivery is really a process to optimize software delivery performance. And the whole study, the way the study is shaped, how they call people who deploy more often elite performers, supports that. Continuous delivery improves security, so the software is more secure, less work on bugs, the time to restore services, so if a service fails, it's easier to get it back online. It improves the time spent on new features, 50% versus 30%, even burnout, the organizational performance, and also, but that should be obvious, time to market. That is something that you should be aware of. And therefore, because it actually impacts organizational performance, even your valuation, the price of your stocks, it is something that is probably very valuable, but on the other hand, you also need close collaboration. It's not enough to just hire a DevOps engineer. If you found the presentation interesting, there is this email address, gotonight2020@ewolff.com. You get a response with a link to a Dropbox with the slides and all the free books. These booklets that sum up the other books, and also with sample chapters from my books. This is powered by Amazon Lambda. It's a small Python, well, let's call it a microservice. So that means your email address is locked for 14 days on the Amazon infrastructure. That's the shortest time period that I could set up there. And if you address your email wrongly, then I will handle it manually. It goes to my inbox and I will handle it. So that's the data privacy disclaimer. And wrongly email addresses, that obviously only works on the left side of the ad, right? So on the right side, you're out of luck. That will never make it to my inbox. Okay, thanks a lot. Thanks a lot for listening. And I hope you enjoyed it, and I'm happy to answer any questions that you might have.
Thank you so much, Eberhard. So yes, there is a question, or at least an argument from Christian. I would argue release equals slash equals deployment. You can find deploy a feature behind a feature toggle, meaning that you're not releasing said feature until the feature toggle is toggled.
Right.
Fine.
Yeah, so that's actually what I said, right? So if you do a deployment of a new version of the software, then that doesn't really mean that you would bring a new feature into production, because you can switch it off with a toggle. So I think we are on the same page here. I'm not sure.
Christian?
Yeah, it's true. But so a couple of slides back, you just mentioned that releasing a new feature equals making a new deployment. And well, that's true, but I was just making sure that there weren't any misconceptions about the fact that releases aren't the same as actual deployments, or deployments aren't equal releases. So yeah, we agree.
Yeah, so that's actually one of the misconceptions that I was talking about, right? That people think if you put new software into production, that actually means that a new feature is out, and that's not true. So, and in particular, if you want to do multiple deployments per day, that doesn't make any sense, because you probably won't have new features out multiple times per day. So there has to be more. So it's obviously a misconception that a new deployment means new features. So thanks for bringing that up again. So that's one of the points that I was trying to make. And it's somewhat weird because obviously I have those slides that present those misconceptions. So it's important to say that they are misconceptions. Otherwise, I will find a tweet at one point that says, Eberhard said on the slide this and that. And, actually I said quite the opposite.
Okay, so Walter, what would be the ideal role of the product owner, product manager in a DevOps organization?
The ideal role of a DevOps, of a product owner, to be honest, I'm not sure whether there is, so that's a good question. I'm not sure, and I should probably say that I don't consider myself an expert on Agile. So maybe an expert on Agile has another idea. I would argue that product owner should prioritize stories and should be able to answer questions about stories. So that's really what they should be doing. And it's up to the team to estimate the effort and to decide how things should be done. Like how are we going to implement that? And that is something that the product owner shouldn't really influence too much. At the end of the day, it's a collaborative game. So, any kind of feedback is welcome. But what I'm trying to say is the product owner shouldn't really have such a big saying in how things are done, because that is really something that technical people like myself consider themselves an expert on. So telling them how they should do it, doesn't really make a lot of sense. The product owner should tell them what should be done. Now, has that any consequence concerning continuous delivery? I would argue that most of the stuff, like implementing the continuous delivery pipeline and so on, is actually up to the team, because it's just how things are done. However, as I mentioned, at the end of the day, if you think about all the ideas with agility and so on, one of the main things is, here is this tool. This tool allows you to put out things in production like every 14 days or even multiple times per day. So here's a big chance to learn from customers. And if you don't do that, then you don't really get a lot of value. So for a product owner, I think it's important to sort of work data-driven and hypothesis-driven. So let's assume that my hypothesis is that customers are much more happy with us if they know where the delivery is. So if we actively push out information about a delivery. So that's a hypothesis. So instead of saying, okay, we are going to implement that, we could try out to implement that for a very, very simple case first, put that in production, get some metrics, learn from that, and then build it for the more advanced cases, and for the more advanced cases, and so on and so on. And if you don't do that, then you won't really get a lot of value out of the continuous delivery pipeline. But at the end of the day, you won't also get a lot of value out of agile processes. And there is a problem there, because what that actually means is, well, I'm the product owner. I know what people want. That's my business. I cannot be wrong about that. And, that is something that you have to give up. Instead, you have to say, this is my hypothesis. This is, I think, how things work. How are we going to test that with as little effort as possible in production? And that is really hard. And I've come across quite a few cases where if you dig deep enough, that is actually not how the project works at all. It's not about improving revenue. It's rather because there is someone who actually wants to say, okay, this is something that we can do. This is a fancy thing to impress people. And that is something that that is quite different from this data-driven approach. So you have to realize which kind of game you're playing, and you have to be able to get as much value from continuous delivery as possible. And I think that's sometimes probably quite hard.
Does that answer your questions? I hope so. There are a couple of comments. So prioritize the backlog and analyze new features. That's...
Yeah, and in particular, cut down features so that they're as small as possible, so that you can learn from it and that you can implement it inexpensively, get it out in production, and then learn from the results. And, you know, basically say, trying to get data to back up your hypothesis.
Okay, so in short, make the feedback loop work.
Yeah.
Yeah.
And
cool.
I think that's still very hard.
Okay, then we have from Patrick. How does manual exploratory testing fit with CD? Would you recommend doing that, or would you OTOH call it an anti-pattern? Seems to contradict automating release decisions.
Yes, and that's a very good question. So first of all, as I said, and that is something that I'm thankful for. So if you look at the study, it actually says that even elite performers don't really have all the testing automated. And I'm thankful for that because it's, I think it's a much more practical approach, or it tells you how things really are, as opposed to what extreme programming said, where they said, well, we have to have 100% automation, which is probably unrealistic. Now, what about the manual explorative test? So I would argue if you want to do multiple releases per day, there is obviously no way how you can do a manual test that is meaningful several times a day. So either the test is meaningful and manual, but then it will last longer. So a short test that you do several times a day, that doesn't really make a lot of sense. However, first of all, there are feature toggles. So you can release new code and you can look at it, and it's not activated in production. So probably you can still have a manual look at it and figure out whether it is really what you want. And so that is something where you can do some sort of manual testing. And I'm not even sure whether I would call it testing. It's rather, you know, is this really what we want? Do we want something different? And the other thing is, so there are cases where you say, okay, in production, we have this problem. Why do we have that problem? Let's try to figure that out. And that is something that you can easily do manual, and it won't block releases because the problem is already there in production. So, you know, you probably have some kind of workaround in production, or maybe it is something that you can deal with. It's something that just needs to be improved, but it's not a blocker. So in those cases, manual testing would make a lot of sense. And again, and I would totally agree that it must not block the release of new software, because that doesn't make any sense, right? That way you can't get multiple deployments per day.
Okay. What do you need to do first before getting to continuous delivery? When can't this be done, or would be a bad idea?
Yeah, so that's a good question. So first of all, I would argue in a way, I mean, somehow you get code into production, right? Otherwise, your project is probably somewhat pointless, or it's at a very early stage. So I would argue it's actually a stepwise project or a stepwise improvement where you try to eliminate the bottleneck at hand. And I don't see why you wouldn't be able to do that. Having said that, there are some cases like, so in Germany, we obviously have a lot of companies that do mechanical engineering and that build some machines that are out there in the factory floor somewhere. And people are somewhat reluctant to install new software on those machines because they're afraid of the risk. And you could argue that in those cases, continuous deployment or continuous delivery doesn't really make a lot of sense, because, you know, getting stuff out in production, maybe those machines are not even connected to any kind of network. So how would you install software there? And, you know, the customer is actually reluctant to install your software. Now, I would argue, and I have to admit that I changed my mind on that a few months back. I would argue you're somehow missing the point with that approach. Because if you look at it, the point I was trying to make is continuous delivery is a way how you can optimize your software delivery performance. So there is that final step, which is stuff goes in production, in that case on some machine, on some factory floor somewhere. Well, is it that important for your overall process? I'm not sure, because you can still deploy on some testing environments. And if you look at it, so I find that quite interesting. One of the original case studies for the continuous delivery book was HP, the printer manufacturer, and it was about HP firmware. So actually I have an HP LaserJet right over there, and I'm not sure when I installed firmware on that machine the last time. So obviously they are not doing that many releases, and they don't do that many updates in production. And it turns out, if you read through that case study, what they actually did is they unified their platform, they did some simulators, they invested in automated testing, these kinds of things, and the result was a better overall performance. The case study doesn't even say whether the deployment frequency in production increased. So I would argue, if you look at these cases, you get a lot of benefits without really doing the final step, putting stuff in production. The other thing I found interesting, so not too long ago, there was an article in, I believe, Financial Times about Tesla. So some Japanese people took a Tesla Model 3, tore it apart, took a look at it, and figured out that the system is quite different from most of the other cars. So there were just two machines in the two IT systems in there, one for infotainment, the other one for actually controlling the car, which is and both are engineered by Tesla. So it actually says Tesla on them. If you do the same thing to some German car, what you will see is a lot of small microcontrollers connected together in a bus system, and each of them is done by some supplier, not by the company itself. What this means is that the whole architecture is different. Even the way the company works is different, because suppliers are handled differently for Tesla and the other companies. And this is the enabler why Tesla is able, or how Tesla is able to roll out changes so frequently. I think that's at least what the article says, because there are just two IT systems in there, while in the other car, you will have a lot of IT systems that you will need to update. So again, because you want to roll out frequently, it has a lot of consequences. It has a lot of impact on the overall organization. And again, the question is whether the final step, putting stuff in production, is so important. And the other point, so that is the one thing. The other point that I want to make there is, so cars are actually something that go through a very rigid process to get some approvals. And in particular in Germany, you're pretty sure, I guess, that Tesla is closely watched. And even in this market, it's possible to do updates on the fly, because that's what Tesla does. So if we have a discussion like we can't really put software in production that frequently, there are actually two answers to that. The one answer is, well, do you really need that final step? Is it that much worth? I'm not sure. And the other answer is it really impossible to get stuff in production frequently? Because Tesla does it. So even if you are some machine manufacturer, why wouldn't you be able to do that, what Tesla does? I'm not sure. But that's up to you to decide, and it's at the end of the day, it's business strategy. So you need to figure that out.
Okay, give me a second. So Anders asks, what would you do in the situation you sketched when business is not listed to the feedback from a CD effort?
Well, obviously, so I would argue there are two things here. So first of all, I would still do the continuous delivery pipeline, and that's one of the reasons why I'm doing this talk and why I'm having this discussion, because I think me as an IT professional, I would rather work in a company where there is a continuous delivery pipeline in place. And that's not just my gut feeling. There is a study that says I'm less likely to have burnout. And quite honestly, I don't care about in this discussion. I don't care about whether business realizes what they have there and what they could have. So that's one answer. The other answer is, well, you still need to talk to people and try to educate them, because and the reason why I would still do that is because at the end of the day, those are the people who actually have the money, and they might at one point say, why are we doing that? Why are we doing continuous delivery? We should stop doing that. It's just a waste of money. And in that case, you're in a bad situation. So I wouldn't give up, but on the other hand, I would still implement it for very, well, egoistic reasons. I'm not sure whether it's egoistic, because for reasons, because it's also quite an important thing for the IT side too.
Okay. Tobias asks, in a still siloed organization, business IT, how to convince business that a move to CD helps? In the beginning, it costs so much.
How to convince business to move to CD because it costs so much? Well, first of all, I'm not sure whether it costs so much, because I mean, if you're working in a software project, I would argue you should be able to improve something and to increase speed. Otherwise, it's probably not going to work out. And I mean, if you just try to do it yourself, people would need to actively stop you from doing it. I'm not sure whether that's very likely. So I would start even without buy-in. The other thing is, I have to admit that, so why are we even doing that? Why are we even, trying to optimize anything? I would argue we are trying to do that because we expect some kind of benefit, and that is probably a benefit that should somehow pay off at the end of the day in euros. What that means is, if you're not able to make that case, at least to yourself, so here is something that I change. Here is what I expect from that change, how things are better. I think it's worthwhile because of X, Y, Z. And, sort of the effort that I invest and the result that I get are somehow, it makes sense. So I get some payoff. If you have that discussion, and you should have that discussion, because otherwise what you're trying to do is probably pointless, then you should be able to convince a business person too. So what I'm trying to say is, I don't think that what I'm trying to say is, if you can't justify an optimization to yourself, and you will probably have to justify it to yourself also in euros, then you should also be able to justify it to a business person. And again, that is about collaboration and to communication and so on. And it's not about, it's not about having the most beautiful software architecture around or the best process around. At the end of the day, it's about money. And if you can't make that case, if you can't say where there is the advantage in terms of euros or dollars, then probably you don't really have a case.
Okay, thank you. At Philip's organization in banking, fear of releasing is quite high. In his opinion, a lot of obliged documentation mixed with predefined release dates is keeping teams away from releasing more often to production. What's the solution to releasing more often when having to do tasks that are required the company orders us to fulfill before releases, like documentation, asserting GDPR compliance on every release, etc.?
Yeah, so again, I think there's a twofold answer to that. So the one answer that I would give is we're looking at an optimization. So just deploying to staging might be enough and doing that frequently. And then again, if you look closely, I mean, in particular concerning documentation and, certifications and these kinds of things, in some cases, because you have continuous delivery in place and because you have that process that is fully automated, some things are just, well, they don't need to be documented, or there doesn't need to be some process in place. It's rather that process is, well, in the continuous delivery pipeline. So, if you say that, I don't know, you have to document changes to production systems, well, if you have a continuous delivery pipeline, the only way to a production system is through the continuous delivery pipeline. So obviously that will be documented. So what I'm trying to say here is, it's sort of, sometimes I'm not sure what the discussion is there. So if you look really closely at certifications, security certifications, process certification, and so on, they are usually quite flexible, and they say these are the goals that need to be done. These are some basic principles, like everything has to be approved by another person, or there has to be some sign-off by another person. And you can implement that in a continuous delivery pipeline. You can just say, okay, this change will be approved by another person. It's part of the continuous delivery pipeline, and it's right here. And in that case, if you have that kind of discussion, then you can have a productive discussion where the certification actually, well, sort of both sides win, I would say, because the certification has a more traceable process, for example, in the specific example, and you have a better continuous delivery pipeline. Sometimes I'm afraid that this is a discussion that is around someone who actually rather has that discussion because he or she is doesn't really want to implement continuous delivery, or doesn't really want to change. So I'm not sure what kind of discussion you have. And then I would either aim for less, so just going to staging, or I would try to see whether I can get those certification and these things in place, even with the continuous delivery pipeline. And again, as I said, it's an optimization. So maybe the last step in production is not that important after all.
Okay. Is that a good answer, Philip? Okay, we have 5 more questions, so and 12 more minutes. So we'll see what we can get. So Alexander has a few good questions. So the first one is, he agrees with the statement that the title DevOps Engineer is nonsensical. However, due to the fact that most organizations are at different stages of DevOps transformation, could you argue that assuming these roles can help market engineers that are aware of these results and want to push this movement forward?
Yeah, sure. So as I said, I mean, I don't have a problem with the title. It's just that the assumption that you somehow hire a DevOps engineer and you build up a DevOps silo in the worst case, that this is something that DevOps said doesn't make any sense. If I have some person that actually wants to make that collaboration happen between Dev and Ops, I don't care what the title of that person is, as long as that person actually makes it happen. So I think that makes some sense.
Okay. So considering a CD pipeline with production deployment done by opening a pull request against a certain repository, and it goes through an approval process, is this pipeline still considered a CD pipeline, or is there a misconception here as well?
I wouldn't see why. So I mean, why I wouldn't call it a continuous delivery pipeline. But I'm not the official. I'm not sure whether I'm the one who has sort of the power to officially define what is a continuous delivery pipeline and what is not. My thinking is rather, there is a pipeline in place. Somehow that pipeline makes sure that stuff goes into production. And for me, continuous delivery is about optimizing that. Now you're focusing on the approval process. And as I said, the approval process is just one of the things that you might want to optimize. So maybe there are other things. And at one point, it's about eliminating those bottlenecks step by step. And the reason why I made the specific slide about the approval process is because I think that's one of the tough things about continuous delivery. And I'm not sure whether people are aware of that. So, if you want to do multiple deployments per day, there is just no way that somehow someone higher up in the hierarchy can sign off each deployment. That's just impossible. So there needs to be some trust in place. There needs to be some automation in place. And I think the reason why I spent the specifics, why I spent one slide about that, is because I think it's not obvious. People think about, you know, automation for testing, automation for the deployment process itself, but even the thought of automating an approval process might be something strange. So I wanted to highlight that this is something that you might want to do too, but it might not be the first thing that you want to do. And maybe there is a lot of other stuff that you want to do first before you do that step.
Okay, so for all automation stuff, a lot of tooling and additional know-how is required for pure devs, config management, CI tools, etc. How to get them on the DevOps train without bothering them with pressure besides the daily work? Failures on pipeline often lead to headless try and error for someone who is not open-minded for DevOps.
Yeah, again, so first of all, I would try to focus on the things that give some great payoff without paying a lot of effort. So maybe if the effort is too high, that's not, and I would do it stepwise. So if the effort is too high, maybe that's not the first thing that you want to do, and or maybe you don't want to do it at all, because, as I said, therefore the payoff and the effort, that is something that you need to focus on. Otherwise, I mean, my personal approach is, if I want people to change behavior, I have to educate them about it. And I think somehow this is often forgotten. So, you know, it's easy to tell people, this is what you need to do, this is how things should be done, but to actually go out there and let them try for themselves, I think it's actually quite important, but it is something that people don't really do. So I do that for domain-driven design, for example. I just have people try it out on some artificial examples. And I hope that people then adopt that. And that's quite different from telling them, well, you need to do this, 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 and this. So one thing that I would try to do is, I would try to find some allies, some people who are interested, try to figure those tools out with those people, try to be open-minded about it, try to support people who are struggling with those tools, and thereby trying to do the change. And again, this is something I think that you can do in a sort of roots fashion, you know, where you just say, this is something that I found valuable. Don't you want to try it too? And I'm going to help you. So that's one way of doing that.
Okay. We have, so what's your view on mono repos? A lot of big names are using those heavily with great success, yet there seems to be a general distrust towards the pattern.
Yeah. So I mean, by now you should have learned that you know, I'm not religious about anything. So maybe it works for some people. So I do know that Google, for example, is a famous example of such a monorepo. But I mean, Google probably has 100 people also working on the tooling, and usually the projects that I do, and I even consider them, well, at least large, they have about 100 people overall on the project. So what I'm trying to say is, I'm not sure whether that is a technique that I would recommend. So let me explain what a monorepo is. So the idea is that everything, like in that case, all of Google, is in one repository, like in one huge Git project. And if you do a change, then you can do a change across all of the code. So you change the library, and then you change all the dependencies of that library in the same commit. That somehow seems to be valuable, maybe. I'm not sure, because obviously there is a huge challenge with that, because you have to have all the tooling to work with these gigantic repositories and to get things deployed. So to me, the more natural approach, and I would even argue that there is sort of a smell around there, because it sounds to me that this actually means, well, I have this large blob and I can't really develop anything in that large blob independently from one another. So you could argue that this is actually a sort of, well, I wouldn't call it an anti-pattern. It's rather solving a problem that should be solved on a different scale. So there should be a better architecture that allows you to evolve those parts independently. So let me put it that way. If I was to start a project, I wouldn't be going for monorepos. I find that it's not unnatural. It is something that I just wouldn't choose. It doesn't seem to be natural to me. It's not the way that I do things. If there is a client and they say we are doing monorepos and we are pretty happy about it, I would be eager to learn more about it. And I wouldn't say it's something that you shouldn't be doing at all. It is just that I'm skeptical, and it seems to me that this might be an indicator that your architecture is actually bad, and that everything is tied together.
Oops. There is one more question, but I think you sort of answered that already. How do you tie benefits coming from continuous delivery with financial returns of organization investing in it? How can I show on balance sheets that it's a sound investment?
Yeah, probably you can't. So I would believe that this is in real life, that's too complex, and that's not what I'm trying to say. So what I'm trying to say is, you have to at least be able to justify your changes, the optimizations that you make, to yourself. And you have to basically say, okay, this is what I'm going to change. This is about how much effort that will be. And this is where I get some positive outcome out of that. And estimating effort, it is something that we do quite frequently in software development. So I would argue you should be used to it, and it's not a precise science. The reason why I even talk about that is because far too often I'm like, I go to some customer and they tell me we need to do whatever, microservices, or we need to do, I don't know, we have to have more documentation. And then I try to figure out what actually the root problem is and what the positive benefits should be. And then we end up with a completely different solution that somehow seems to solve the problem. And this thinking about what is it that you really want to achieve, and is it worth it, that is something that I want to encourage people to do. I think it's an illusion to think that you can put it down in a balance sheet. And as I said, that's not a precise business. And also, I mean, just looking at costs and balance sheets, that's not the point. If you have, it's more than that, right? I mean, if you have the ability to put stuff out more frequently, that is something that doesn't really resonate on the balance sheet. It is an investment, like the investment in a machine, but I'm not sure whether, on the balance sheet it says, oh, we have this fancy continuous delivery pipeline and it's valued at $1 million. That's probably not what works there, even though that's how it should work, right? Because there is an investment, and an investment in a continuous delivery pipeline is to me quite comparable to an investment in a machine. And the machine is obviously in the balance sheet. It says, this machine, that much is money has been invested. So I think it breaks on that level, but it's still it's this mindset that is important.
Okay, well, thank you so much, Eberhard. I think we can all applaud. This was a wonderful talk, and thank you so much for taking the time to answer all these questions. I hope everyone who asked questions is happy. Yep, thank you very much. So yeah, for everyone, thank you very much for joining. And you have Eberhard's email. I did post it in the chat as well. And I've posted Slack, and I've recorded this talk, and I'll put it on our YouTube channel called GOTO Night Live. And here is the link. So bear with me. It takes a while to upload it and download it and change it and everything. So it'll be there. So thank you very much, Eberhard. I'll keep you updated. We'll chat tomorrow. Or do you have any questions?
No, thanks a lot. Thanks a lot for having me. Thanks a lot for all the questions. So I enjoyed that quite a lot. Discussing things and answering your questions. So thanks a lot for that, and hope to see you at one point, maybe in person even.
That will be nice. That will be. So let's hope in October, right? And go to Berlin.
Yeah, you didn't give the date. Yeah, did you?
28th to 30th of October, right?
The year.
The year. Well, the year is, we are hoping 2020.
Yeah.
Our fingers are crossed. We'll see. Hopefully there'll be a vaccine by then. And
yeah, it's the best practice for project managers, right? So if you give a date, never give the year. We actually delivered in October.
Fair enough. But I think if we have to cancel this year, we will do it virtually. So the conference is not canceled.
Right. So. Yeah. So I'm looking forward to the conference. I enjoy GoToCon always. So I'm looking forward to that. Okay.
Wonderful. We're looking forward to it as well, and hopefully in person. So thank you very much, everyone. Eberhard, I'll send you an email tomorrow. And thank you. And it's lovely to see so many known faces and names.
Yeah. Thanks a lot. Thanks a lot for sharing the videos. That's also nice. So that I can actually look at the audience. So that's great. Okay.
Yes, we prefer that. Bye. Have a nice evening, everyone.
Bye.
See you soon.
Cheers, Eberhard.
Ciao. Bye, Gary.